Question. A projectile launcher is set at an angle of 45 degrees above the horizontal and fires an object with a speed of 2.2 multiplied 10 to the power of 2 meters per second. The object lands at the same height from which it was launched. Air resistance is negligible. Calculate the object's A. Time of flight, B. Horizontal range, C. Maximum height, D. Velocity at impact with the ground. Its initial velocity is 2.4 multiplied 10 to the power of 2 meters per second, and this is 220 meters per second. And the angle between the direction of the initial velocity and the horizontal line is 45 degrees. So theta equals 45 degrees. So I draw the initial velocity here. So this direction is the positive y direction. This direction is the positive x direction. And this is just the initial velocity. And this angle, the angle between the direction of the initial velocity and the horizontal line is 45 degrees. And it says here, the object lands at the same height from which it was launched. So the height of its starting point is the same as the height of its ending point. So A. The time of flight. In the previous video, we have analyzed such a situation, and we know that it's the time of flight, the time interval just equals 2 multiply the initial velocity multiply sine theta divided by acceleration g. So this is just the formula for the time of flight, but this formula is just for the situation that its starting point is at the same height as its ending point. So it's the constriction for this formula. So this equals 2 multiply 220 multiply sine 45 degrees and divided by 9.8, and this equals 31.75 seconds. And B, the horizontal range. So from the previous video, we already know that for such a situation, its horizontal range is also called its horizontal displacement, just equals the initial velocity square multiply sine 2 theta divided by the acceleration g. Then this equals 220 square multiply sine 2 theta. Sine 2 theta is 2 multiply 45 degrees. So it's a sine 90 degrees. So sine 90 degrees is 1 and divided by 9.8. And this equals 4938.78 meters. Now C, its maximum height. We know this formula, the final vertical velocity square equals the initial velocity multiplied sine theta square minus 2 multiply acceleration g multiply the vertical displacement. From this formula, we can get the vertical displacement just equals the initial velocity multiplied sine theta square minus the final vertical velocity square divided by 2 multiply acceleration g. When the final vertical velocity is 0, this guy will get its maximum value. We can also defer that when the object reaches its highest point, its vertical velocity is 0. So when the vertical velocity is 0, the object is at its highest point, and its displacement would get its maximum value. So we can get that its maximum height just equals the initial velocity multiplied sine theta squared divided by 2 multiply acceleration g. And this equals 220 multiply sine 45 degree squared divided by 2 multiply 9.8. And this equals 1234.69 meters. So its maximum height is just this value. Now for question D, the velocity at impact with the ground. We should know that at such a situation that its launching point is at the same height as its landing point, then its initial velocity is this direction, and this angle is theta. Then its final velocity should be this guy, and this value is also theta. So this is its initial velocity, and this is its final velocity. The direction of its initial velocity is theta angle theta above the horizontal line. Then the direction of its final velocity is theta angle and below the horizontal line. And the magnitude of the initial velocity is the same as the magnitude of the final velocity. So we can know that its final velocity just equals the magnitude is also 220, the same as its initial velocity's magnitude. Now its direction is, we know for this question, the theta is 45 degree. So the direction of the final velocity is just 45 degree and below the horizontal. Here is also 45 degree. The direction of the initial velocity is 45 degree above horizontal. Then the direction of the final velocity is just 45 degree below the horizontal.